Have you ever looked up at the sky after a rainstorm and been greeted by a beautiful rainbow? It's a sight that never fails to amaze, a natural wonder that seems almost magical. The sky, once dark and stormy, transforms into a canvas of vibrant colors, as if nature itself is celebrating the end of the rain. Rainbows are like a giant arch of colors painted across the sky, a bridge between the earth and the heavens. They appear so suddenly and so vividly it's hard not to stop and stare in awe. But what exactly is a rainbow? How does it form, and why does it appear after a rainstorm? The answer lies in the interaction between sunlight and raindrops. When sunlight passes through raindrops, it bends or refracts and then reflects off the inside surface of the droplet. This process separates the light into its component colors, creating the spectrum we see as a rainbow. Rainbows have captivated people for centuries, inspiring countless myths and legends. In many cultures, rainbows are seen as bridges to the divine, symbols of hope and promise. Ancient Greeks believed that rainbows were the paths taken by the messenger goddess Iris, while in Norse mythology, the rainbow bridge Bifrost connected Earth to Asgard, the realm of the gods. But beyond the myths and legends, there's a fascinating scientific explanation behind their formation. It's true. Rainbows are a perfect example of the way light interacts with water in our atmosphere. This interaction is a beautiful demonstration of the principles of optics, the branch of physics that deals with the behavior and properties of light. When sunlight enters a raindrop, it slows down and bends as it moves from air to denser water. This bending of light is called refraction. The light then reflects off the inside surface of the droplet and refracts again as it exits the droplet, spreading out into a spectrum of colors. This process happens simultaneously in millions of raindrops, creating the circular arc of a rainbow. Rainbows appear when sunlight interacts with raindrops in a specific way. The angle at which the light is refracted and reflected inside the droplet determines the position and size of the rainbow. Typically, the primary rainbow forms at an angle of about 42 degrees from the direction opposite the sun. It's all about light, water, and a little bit of physics. The colors of the rainbow are always in the same order: red on the outer edge, followed by orange, yellow, green, blue, indigo, and violet on the inner edge. This sequence is due to the different wavelengths of each color of light, with red having the longest wavelength and violet the shortest. Understanding the science behind rainbows makes seeing one in the sky even more amazing. It's a reminder of the incredible beauty and complexity of the natural world. The next time you see a rainbow, take a moment to appreciate not just its beauty, but also the fascinating science that makes it possible. So let's dive in and explore the science behind these beautiful displays of color. From the myths and legends of ancient cultures to the principles of modern physics, rainbows are a testament to the wonder and beauty of our world. Join us as we uncover the secrets of these stunning natural phenomena. The first ingredient in our recipe for a rainbow is sunlight. Sunlight might look white or yellowish, but it's actually made up of all the colors of the rainbow combined together. We call this combination of colors the visible spectrum. Think of it like mixing all the paints in a paint set together. You get a brownish color that's not as vibrant as the individual colors themselves. When sunlight hits a raindrop, something amazing happens. The light doesn't just pass straight through the water, instead it gets bent and bounces around inside the raindrop. This bending of light is what allows us to see those distinct rainbow colors. The bending of light as it passes from one medium to another, like from air to water, is called refraction. This fascinating phenomenon is not just a simple change in direction, it's a gateway to understanding the behavior of light and its interaction with different materials. When light encounters a new medium, its speed changes, causing it to bend. This bending is what we call refraction, and it's responsible for many everyday optical effects that we often take for granted. It's the same phenomenon that makes a straw in a glass of water look bent at the surface. This apparent bending occurs because light travels at different speeds in air and water. When light moves from air into water, it slows down, causing the light rays to change direction. This change in direction makes the straw appear to be bent at the point where it enters the water. This simple observation is a direct consequence of the principles of refraction at work. Imagine light as a car traveling along a road. On a smooth, paved road, the car moves quickly and in a straight line. However, when the car encounters a different surface like a muddy patch, its speed and direction change. This analogy helps us visualize how light behaves when it moves from one medium to another. When the car hits a patch of mud representing the water droplet, it slows down and changes direction slightly. Similarly, when light enters a water droplet, it slows down because water is denser than air. This change in speed causes the light to bend, just like the car changes direction when it hits the mud. The degree to which the light bends depends on the angle at which it enters the new medium and the difference in density between the two media. Similarly, when light enters a water droplet, it slows down because water is denser than air. This slowing down of light is crucial in creating various optical phenomena, such as rainbows. When sunlight enters a raindrop, it refracts or bends at the surface of the droplet. The light then reflects off the inside surface of the droplet and refracts again as it exits the droplet, creating the beautiful spectrum of colors we see in a rainbow. This change in speed causes the light to bend. The bending of light through a prism or a water droplet separates the light into its constituent colors, a process known as dispersion. Each color of light has a different wavelength, and as a result, each color bends by a different amount when it passes through a medium. This separation of colors is what creates the vibrant spectrum we observe in rainbows and through prisms. The different colors of light bend at slightly different angles because they have different wavelengths. Red light, which has the longest wavelength, bends the least, while violet light with the shortest wavelength bends the most. This difference in bending angles is what spreads the colors apart, creating the full spectrum of a rainbow. Red light bends the least, which is why it appears on the outer edge of a rainbow. The longer wavelength of red light means it is less affected by the change in speed as it moves from one medium to another, while violet light bends the most. Violet light with its shorter wavelength is more significantly affected by the change in speed, causing it to bend more sharply and appear on the inner edge of the rainbow. This beautiful interplay of light and color is a direct result of the principles of refraction and dispersion at work. As sunlight enters a raindrop, it's refracted or bent. This bending occurs because light travels at different speeds in different mediums. When light moves from the air into the denser water of the raindrop, it slows down and changes direction. This process is known as refraction and is the first step in the creation of a rainbow. The different colors of light are separated because they bend at slightly different angles. Each color in the spectrum has a unique wavelength, and these wavelengths determine how much each color will bend. For instance, red light has a longer wavelength and bends less, while violet light has a shorter wavelength and bends more. This separation of colors is what gives a rainbow its distinct bands of color. This separation of colors is similar to what happens when light passes through a prism. A prism is a transparent optical element with flat, polished surfaces that refract light. When white light enters the prism, it is split into its constituent colors, just like in a raindrop. This phenomenon is known as dispersion, and it is crucial for the formation of rainbows. The light then reflects off the back of the raindrop and is refracted again as it exits the droplet. This internal reflection is essential because it allows the light to be directed back towards the observer. Without this reflection, the light would simply pass through the raindrop and continue on its path, and no rainbow would be seen. This double refraction is what causes the rainbow effect. The light undergoes two refractions and one reflection inside the raindrop, which results in the light being spread out into a spectrum of colors. This process is repeated millions of times in millions of raindrops, creating the beautiful and vibrant arc of colors that we see in the sky. Because each color of light is refracted at a slightly different angle, the colors fan out, creating the arc of a rainbow. The angle at which the light is refracted and reflected determines the size and shape of the rainbow. Typically, a primary rainbow forms a circle with a radius of about 42 degrees, but we usually see only an arc of this circle because the ground obstructs the rest. Red light, bending the least, appears on the outer edge of the rainbow, while violet light, bending the most, appears on the inner edge. This arrangement of colors is consistent in every rainbow and is a direct result of the varying degrees of refraction for each color. The next time you see a rainbow, you'll know that it's the result of a complex interplay of light and water, creating one of nature's most beautiful spectacles. Beyond the rainbows in unexpected places. While rainbows are most commonly seen after rain, they can actually occur whenever there are water droplets in the air and sunlight shining at the right angle. You might spot a rainbow near a waterfall, a fountain, or even in the mist created by a garden hose. The key ingredients are sunlight and water droplets, regardless of whether those droplets are falling as rain or suspended in the air as mist or fog. So keep your eyes peeled for rainbows, even on days when it's not raining. Double the delight, the mystery of double rainbows. Sometimes you might be lucky enough to see a double rainbow. A double rainbow occurs when light is reflected twice inside each raindrop. The second reflection creates a fainter secondary rainbow above the main one. Interestingly, the colors in the secondary rainbow are reversed compared to the primary rainbow. This is because the light takes a slightly different path inside the raindrop during the second reflection. Chasing rainbows. Why they seem so elusive. You've probably heard the saying, "You can't chase a rainbow." There's a scientific reason for this. A rainbow isn't a physical object that exists in a specific location. It's an optical illusion that's created by the interaction of light and water droplets. The position of a rainbow depends on the angle of the sunlight and the position of the observer. As you move, the angle changes, and the rainbow appears to move as well. So while you can't reach the end of a rainbow, you can certainly enjoy the chase. A kaleidoscope of colors. Understanding the spectrum. The colors of a rainbow always appear in the same order: red, orange, yellow, green, blue, indigo, and violet. This order is determined by the wavelengths of light. Red light has the longest wavelength, while violet light has the shortest. When light is refracted, the different wavelengths are separated, creating the spectrum of colors we see in a rainbow. This spectrum is a beautiful reminder of the complexity and wonder of light. More than meets the eye. The science behind the magic. Rainbows are a captivating reminder that there's often more to the world than meets the eye. What seems like a simple arc of colors in the sky is actually the result of complex interactions between light, water, and our own perception. Understanding the science behind rainbows doesn't diminish their beauty, it enhances it. Knowing how rainbows form allows us to appreciate the intricate workings of nature and the amazing phenomena that occur all around us. Rainbows, a timeless source of awe and inspiration. Rainbows have been a source of awe and inspiration for people across cultures and throughout history. They symbolize hope, promise, and the beauty of the natural world. Next time you're lucky enough to witness a rainbow, take a moment to appreciate the science that makes this magical display possible. It's a reminder that even the most seemingly ordinary things like sunlight and raindrops can create extraordinary beauty when viewed through the lens of scientific understanding. So, keep your eyes on the sky, and you never know when you might catch a glimpse of this breathtaking phenomenon.